My dear students, hope you are enjoying lockdown vacation. But it is not the right time to enjoy the vacation. The main purpose of giving vacation is to take care of yourself and to stay at home. So while staying at home, you need to improve your knowledge, enhance skills, technical skills. So to engage you all, today I would like to present a video lecture on Tannery wastewater. You see, Tannery wastewaters are one of the most complex cases of treatment and disposal of industrial effluents. Raw materials are organic, as those coming from food industries, but with the main difference regarding chemical process in which both organic and inorganic reagents are used. The effluent, as for food industries, requires a large amounts of oxygen to reduce the organic matter, but contains chemical reagents which are toxic or harmful for biological reactions. In case of high concentration, all chemicals are able to inhibit any reactions. In order to discharge into public sewer or receiving water, a specific and tailored wastewater treatment plant must be carefully designed considering the type of tanning method adopted. The tanning method may be of vegetable tanning or chemical tanning. In chemical tanning, we use chrome as the tanning material. The main steps of production cycle can be summarized as follows. The first step is soaking, then liming, deliming, pickling, tanning, dyeing, fattening, and washing. These are the steps involved in the production cycle in a tannery industry. What are the major pollutants in a tannery industry? Tannery wastewater composition depends on the tanning process, whether vegetable tanning or by means of chrome tanning. Effluent is composed by discharge from several processes and from cleaning operation. The pollutant load is normally evaluated from the concentrations of some parameters like COD, sulfides, chlorides, chromium, ammonium nitrogen, and sulfides. The COD could have very high values up to 10,000 milligrams per liter, but depends on the treatment used. It can be reduced up to 90%. Effluent from the vegetable process has a high BOD value and therefore a very high oxygen demand. That one coming from the chrome tanning has high trivalent chromium concentration. The typical water consumption ranges from 40 and up to 90 liters per quintal of fresh leather processed. Most part of the used water, say for instance up to 50%, is lost by evaporation. During the post-production step, the produced effluent contains also salts, mostly the chlorides, used to preserve hides and to block petrificative phenomena during the transportation of raw material from production area, that is from the slaughterhouses to tanneries. The effluent coming from the different working phases is characterized by variable pH values from very alkaline to very acidic, with values ranging from 3 to 4 and up to 11 to 13. Wastewater management is currently a serious problem that has no easy solution for the tanning industry. And layout of the system. Tannery wastewater do not have a high biodegradability degree and need to be treated by a standard biological treatment plant and high mixing ratio with the domestic effluent. Before this mixing, chlorine and sulfides must be removed and pH correction must be adopted. Very often, since this kind of industries are usually built far from civilian settlements, the mixing with the domestic effluent is not possible. In these cases, a targeted treatment is strictly necessary. The main objective of clarification phase is the removal of all materials not already removed in the pre-treatment. such as suspended solids and various constituents like fats, waxes, mineral oils, floating non-fatty materials, etc. The sedimentation process reduces suspended solids in the BOD. Acid and alkaline effluents are collected separately in different mechanical pretreatment lines and then they are mixed together. Acid water is used as a neutralizing reagent, coagulant for alkaline water. Nevertheless, the final pH is still alkaline and requires reagent dosing. Downstream to mechanical pretreatment, neutralization, and chemical dosing, the most common used process is biological secondary treatment. Usually, only aerobic systems are used due to characteristics of Tannery effluents, primarily to their sulfide content, while anaerobic treatment is used in sludge digestion. The most widely used method is the activated sludge treatment with extended aeration and other biological systems such as membrane bioreactor has not been successful in this area, but they may be developed in the future. Sometimes other solutions can be adopted as biological filtration or trickling filters, but often they have problems due to calcium buildup. In order to avoid this phenomena, it would be necessary to precipitate the calcium carbonate prior to the filtration phase. Where biological treatment is not enough or where high performance is required, specific treatments such as chemical, physical treatment methods can give good results. For example, the chlorination allows the removal of sulfides. Anyhow, these kinds of plants are very expensive in terms of purchase and installation. And for reagents, considering their constant use for all useful life. For example, the chlorine consumption can be estimated from 2 to 8 parts for each hydrogen sulfide. Part to remove coagulation by ferrous sulfide is not recommended because it creates colloids which are difficult to disperse or dehydrate. A typical Tannery wastewater treatment divided into 4 lines. A typical example of physical chemical treatment plant is made up of 4 separate discharge lines. First one, pre-tanning. Second one, chrome tanning. Third, fattening. And fourth, dyeing and washing. The first and the second treatment lines have an equalization and homogenization section, a mixing tank for reagent dosing, and a final settlement basin. A vacuum filter dries the sludge coming from the second line that contains chromium hydroxide. Fattening water is treated with a degreasing and floating tank. Treated waters coming from different lines are then mixed and stored into the final equalization basin and after that discharged into the public sewer. The reverse osmosis has been applied in different effluent discharging lines and has the important advantage to recover and reuse the concentrate. One important thing, a better organization of craftsmanship process and the water recovery should lead to a reduction of the water consumption and therefore less wastewater to treat and to discharge. That is nothing but the zero discharge. Zero discharge is nowadays gaining momentum. As such, in zero discharge, there won't be any liquid waste coming out from the industries. Whatever the waste water they produce, they reuse and recycle to recover the solid waste from the wastewater. So to attain zero discharge is the prime concern for all the tannery industries. The removed pollutants, for example, the chrome can often be recycled within the production cycle. Money saved by the reuse of reagents reward investment for the treatment plants. That's all the tannery waste treatment plant. How the leather is being produced, how the wastewater is being treated, and how they attain the zero discharge. Thank you all.